Welcome to Solar Engineering Service 2, Module 2. Today, we will look at system voltage and why modern utility-scale solar panels use 1,500 watt systems to reduce cost and improve efficiency. Here's why modern solar plants use 1500 watts with higher voltage. Each stream can hold more modules. That means fewer streams, fewer cables, and lower BOS cost. This one design choice saves minutes. System voltage is the maximum DC voltage that PV array can reach under cold conditions. It's defined by electrical coders and inverter hardware limits, with common levels at 600, 1000, and 1500 watts. System voltage determines how many modules you can place in a stream. It affects cable sizing, BOS cost, and overall system safety. Rooftop systems historically used 600 watts. Commercial and utility scale systems use 1000 or 1500 watts. Higher voltage means longer streams and fewer parallel connections. Module voltage rises in cold weather and drops in hot weather. That's why we always calculate open circuit voltage at the coldest expected temperature. We compute the stream open circuit voltage at colder temperature and ensure it stays below both the system voltage limit and the inverter's maximal DC voltage rating. Higher system voltage allows more modules per stream, reducing the number of parallel streams and lowering cable losses. Longer streams reduces home run cables, combiner boxes, and installation labor, significantly lowering BOS cost. As voltage increases, safety requirements become stricter. Disconnects, fuses, breakers, and insulation must all be rated for the system voltage. In a 1500 watt system using 550 watt modules, cold temperature open circuit voltage increases to about 54.5 watts. This limits the stream to around 27 modules. Rooftop systems typically use 600 to 1000 watts. Utility scale plants use 1500 watts for efficiency and cost savings. As system voltage increases, the maximum number of modules per stream also increases. At 600 watts, we are limited to around 14 modules. Moving to a 1000 watt system raises the limit to about 22. And at 1500 watts, we can reach 27 modules per stream. Higher system voltage allows longer streams, fewer parallel connections, and a more efficient overall design. Now that we understand why 1500 watt matters, let's size the stream correctly. In this module, we explored why system voltage is one of the most important design decisions in PV engineering. Higher voltage allows longer streams, reduces balance of the system cost, and improves overall efficiency. We also look at low temperature effects, open circuit voltage, and why cold weather calculations are essential for safe design. These fundamentals prepare us for the next module, where we apply those concepts to real stream sizing. In the next module, we will learn how to size streams using temperature, inverter limits, and module specifications. This is where everything comes together. You will see exactly how engineers determine the maximum number of modules per stream in real projects. If you found this series helpful, feel free to like and subscribe. It helps more engineers discover this content and supports the growth of Gamma Classroom. Thank you for watching. I will see you in the next video of Solar Engineering Series 2.